To analyze a 3D portal frame having a slab load and a horizontal load, we need to click on to this icon STAAD.Pro V8i. Double clicking on that one, we will enter into a STAAD.Pro software. Now we are going to analyze 3D portal frame. For this analysis to be continued, we need to click on to this new project, then click on to the space, then type 3D 3D frame, and we need to look into this location where we are saving these files. Then the unit of this portal frames are length is in meters and load that force is in kilonewton. Then click next. Then the add beam is automatically ticked and click finish. After waiting for some time, then this window opens for STAAD.Pro analysis. Then we need to uh, close this snap node beam by clicking onto this window here. Next we need to create a 3D portal frame. For that, first we will create a 2D portal frame. From there we will translate into 3D portal frame. For that we need to type 0 comma enter. Then we will have a height of 3 meters. So x is 0, y will be 3 again, then x is 0 only, then y will be 6 meters. So this is the way we are going to create a 3D portal frame from 2D. So we can create a columns by selecting the add beam. By clicking onto these nodes like this, we can easily calculate two columns one over the other. Now we need to click escape, then select these columns, then go to geometry, translation, repeat. First we are going to repeat in the x direction, then will be in y direction. X direction, the number of steps will be 1, the distance will be 3, link the steps, open the base and click OK. So now we have created a 2D portal frame. Now we need to create a 3D portal frame. For that we need to select whole 2D frame, then go to geometry, go to translation, repeat, z direction, same spacing is same and we are making a one step only. So again link step, open base, click OK. So now we can easily see that we have a 3D portal frame on our hands. So now what we have to do is, for this we need to create a material properties, support condition and loads, and also design. These four things are left. For that, to give a property, go to general properties, then go to define, select a rectangle, depth will be 0.4 and y will be 0.3, 300 mm and 400 mm. For this beam we are going to click add, then again we are going to create a column dimension of 0.5 by 0.5. This is square column and click add. So we'll close this one. Now we don't want unwanted selected elements, so just click on to this one, it will be unselected. Now first one is beam, so we need to highlight that one, go to geometry, translation repeat, not translation repeat, go after clicking onto this beam properties, go to select beams parallel to x, beams parallel to z, then automatically assign to selected beams will be selected, then click assign. Now we can see first property is given to beam, second property should be given to column. Highlight the column dimension, go to select beams parallel to y, then automatically assign to selected beam is selected, then click assign yes. Now here we can see that all the beams and columns have been given a property. For confirmation, for confirmation, of any missing property is there means we can go to select, go to missing attributes as missing properties. Now we can see no entity with property is missing, so we have assigned the material property correctly. Now we'll change the views to front view, go to general, support, create, fixed support, add, then click on to this fixed support, select these nodes like this. If you see from 3D, we can all the four nodes are selected, automatically assigned to selected nodes have been selected, then click assign. With this we can see that support properties have been given to the this 3D portal frame. Now we need to assign loads to these frames. Now for that we need to go to general, loads and definition, go to load cases and details, click add, then here in the drop down menu click dead, type DL, click add, then in the drop down menu select live, then type LL, click add, then go to auto load combination, select Indian code, generate load combination, click add and close. We can here also we can see there are two load cases and four load combinations. Inside these load cases we need to create loads. So for that click on to the dead load, click add, select self weight, then it is in the -y, click add and close. Select the self weight, select assign to view, then assign yes. We need to assign that one. So all the properties of self weight is assigned to whole portal frame. Next click on to live load, click add, go to member load, minus that member load, we don't have a member load, so here we need to go to nodal load, click on to live load, click add. Now we have a nodal load, go to nodal load, and the load will be in x direction, positive x direction, 50, 50, then 51, click add. Next one is 10 kilonewton, click add. After this we'll go to the floor load. We are applying a floor load as a slab load. So for that one we need to create uh, first load is -5 kilonewton per meter and the range is 0 to 3 meter. First, for the first floor only it is applied, so it is a two-way slab, click add. Then next one is for the top floor we need to have another floor load. For that we need to type -3, same floor load -3, and the range is from let's say we will go a little bit higher. 4 maximum, minimum is 4, maximum is 6. Then click add, then close this one. Now we need to add the fixed load. So here we can see that already the loads of floor load has been applied. Now we need to add the point load onto these edges. For 50 kilonewton, select in between. If DS comes, we need to save this file. Then use cursor to assign. As we have highlighted, then use cursor to assign, click assign. Now we can see that here I am applying 50 kilonewton here, and also I will apply here. Then next one is -10 kilonewton, same, already it is in the assign mode. Just click onto the node here. Now we need to see the load value, means just right click onto this one, go to labels, scale, scale, label, scale is okay. We can go to labels, values, just apply that one. Here we can see that our loads, how it is applied. So this is the UDL, and it is showing in kilonewton per meter, but we have applied in kilonewton per meter square. 50 kilonewton point load and 10 kilonewton at the first floor level. So click OK. After that, after applying all this load, we need to go for analysis. Go to command, analysis, perform analysis, click all, OK, commands, post analysis, analysis result, click yes. Then analyze, run analysis, yes, save. Now we need to see that the analysis runs uh, without any error. Now in this analysis has completed without any errors and warnings. Now we are going to stay in the modeling mode only and click done. For the reason of design, we need to stay in the modeling mode. Go to design, concrete, select IS456, select the parameters. We don't want unwanted things, only we want FC main and F5 main. Click OK. Now we will define these parameters. Go to define, select FC, type 25 MPa, that is 25,000 kilonewton per meter square. Click add, then F5 main. You need to select 415000. Click add and close. After this one, we need to assign this to and view. Select this one, click assign to view, assign yes. Select this F5 main, assign to view, assign yes. Now we need to design beams and columns. For this we need to go to commands, go to design beam, click add, design column, click add, take off, click add and close. Now we don't want to select all the frames, just click and unhighlight all the selected elements. Go to design beam, go to select beams parallel to X, then go to select beams parallel to Z, then assign. Yes, now beam design is assigned to beams. Now design of column, select, go to select beams parallel to Y, then we automatically assigned to selected beams are assigned. So click assign, yes. By doing that one, beam design is assigned to beam, design of column is assigned to column. Now we will go to analyze, run analysis, just save and complete the analysis. Now we can see here that analysis has completed without any errors and warnings. Now we will see the input uh, output file. So click on to this output file, click done. Here we can see the concrete quantities have been calculated, and here also we can see that beams design, columns designs are performed. Here you can see the column designs are performed, and like that if you go to the top, here we can see the beam numbers are also and design also performed on this one. So with this design is performed, and here and the results of input output, all the files are present in this output file. Now we'll close this file. We need to go to post processing, go to modes, post processing. We don't want these load cases, we want only combinations. Click OK. Now we can go see the reaction forces node. Click on to the reaction. Here we can see that reaction forces for each support, bending moment, vertical, horizontal load, as well as bending in x, y, x and z directions are present. Now we can see the displacement. Here displacement is very small, that can be seen using go to labels, right click and labels, then go to scales. Here 1000 we can reduce to 5, something like that. Then we can see that, click apply. Yes, this is the displaced in the horizontal direction. Click OK. Now go to beam. Here also we can see that the bending moment diagrams of each beams and columns are present. Now we can see the bending moment value by going into results, view value, beam results, click maximum, annotate, or end, annotate. So we can see this bending moment diagram, and we will remove all this. Another one is a graph where any one of the beams or columns are double click, and we can see the shear design, deflection, concrete design, and shear forces at each points can also be seen in this window. Close this one. In the end, now we are going to see the shear force diagram just by right clicking onto labels, then go to scale, loads and results. Here shear YY, and load show arrow, this one will remove and apply. And if you see that one, here we can see the shear force diagram of this frame. Then we'll close onto this one. Then we'll go to results, view value, click on to beam result, maximum shear force, click annotate. Now we can see the maximum shear force diagram of this portal frame, and we'll remove all this. In the end, we need to do animation. For this, go to animation, select section distance. Already scale is has been given in the previous steps. So click apply and do the see the animation. The building photo frame is moving in horizontal direction, just like during the earthquake or wind force condition. With this, we are going to end this video.